Hey, Dustin Vanoy here. I had a recent session at PASS Data Community Summit that was part of the Become an Azure Data Engineer learning path. And so we had all these demos that we came up with, and I had to kind of edit them down quite a bit. And so this piece that was not the focus there, but I think is interesting, I wanted to dig into for those that are interested, is about how we deal with kind of the refined layer. So we talked about a raw layer, which is the data's almost direct copy from the source system, do as little transformation as possible. Having a refined layer where you might start doing joins and enrichment and things, but you're definitely going to clean up some stuff. And what I'm going to do in the refined layer in particular in this video is get change data feed set up and ready to go so that anything else that happens downstream will only deal with what's changed. And I'm not stuck dealing with the whole data set every time I do the processing. So at the raw level with this data set, it's a file dump. I have the whole data every time. In Refine, we're going to do the calculations needed to figure out what has changed, what's been deleted, so that then every other step, especially my curated step that's next, would be able to take advantage of the change data feed. So we're really looking at change data feed, delta merge, and then some logic that's been around forever. One way of doing the way to check what has changed, what has updated, what has been deleted, in order to build out that change data feed that we just don't get from the source system in this case. So hopefully this is a helpful dive into it. Let's get right into it and check the description for links to more details on like concurrent processing that I'll use, more details on error handling that'll probably come in the future. Subscribe to the channel, click the notify button if you want to know as I release more information that might explain some of the practices I use in this notebook. But most importantly, you're going to see how do we deal with Delta Lake, how do we deal with change data feed, and kind of what I'd recommend for a fairly dynamic refined layer of your data lake. Let's dive in. So here I'm in my refined notebook, which is part of the solution to processing refined tables that I showed in my PASS Data Community Summit session. The first things I do is I go ahead and run this utility notebook mount storage, which lets me basically import some functions that I can use is basically what that's doing. One of those functions is a way to mount Databricks ADLS directories in Databricks. And so I mount Data Lake Raw, Refined, and Curated, which means you could take similar idea for mounting and use that with your own storage account, assuming you get the credentials and things set up properly within your own secret scope in Databricks. So see my GitHub if you want to go look more at the mount storage. I won't go really through that right now, but it's the mount storage Python file here or notebook, and you can take a look at that and deal with that. Okay, once you have something mounted though, basically here's the steps I go through. First, I do some imports and set up my paths and my formats, Parquet for raw and Delta for refined. Sometimes I will use Delta for raw as well. Usually I kind of wait until I have a reason to use Delta. But in this case, I think the way I was expecting to get the data is Parquet, and so that's what I'm using. Create database is important. You may not need it in your notebook for every time you run it. For me, since I do demos, I tend to set drop equals to true here and recreate the thing. And so this is a function for drop if exist, create if not exist that you can use. And you'll see this a lot in my different demos. All right, now we're getting into things that matter here. We actually are going to do this change data feed in the notebook I end up calling, but this is an example of how we enable change data feed for all Delta tables we create within this session. So this is the way I found to be kind of the easiest if you're using notebooks to just get this enabled while you're doing all of your work with these refined tables. This code is a way for me to just test out the delete logic. Since I've already tested it, I know my delete processing works. I don't think I'll walk through that. It's a little bit quirky to try and manually delete some fields and then see them flow through the process, but that's what that code's for if you're looking at the notebooks on your own. All right, we're getting more into the meat of this now. So I need to build up a list of really tables and the arguments related to those tables in order to do the processing from a full raw copy that I get. In this case, it'd be monthly. I get this full raw copy monthly of consumer index data from data.gov. And I want to go through and process these and see, to refine, I want to eventually only have updates and deletes and inserts go there. I don't want to update every record, both in refined and in curated, right? I want to figure out what's changed and only apply those changes to refined in order to make that step from refined to curated much easier and track better metadata about what's changed and what's deleted. So basically what we have here is 4 dictionaries, 1 per table. Each dictionary has the table name. So in this case, table is area. Has an ID column. In this case, the ID column we'll use for join conditions is area code. And it has a list of columns that we need to use in processing. In this case, there's only 3 of them, pretty straightforward. And so what it's going to do is the same concept as looping through a list of tables, except I'm going to do it concurrently so we don't have to wait for area to complete before the series table kicks off. The core of the logic that we're going to call, this is a Python function. And so load table function is going to take that whole dictionary as args, and it's essentially going to pass that into a notebook where all the logic is. So we are going to spend some time looking at this notebook, which actually does the processing. But this this line here that I'm on is an example of how you can call a notebook and get a status back from Databricks. And so it's a really, you can decide whether you want to put all the logic into a single notebook, like I've shown in past videos, or you want to call a separate notebook. It's hard for me to say exactly when you choose one over the other. I think a lot of it's going to be preference for your team. Oh, one note here is if I get a status back that's not success, then I know something happened, and I'm going to pretty much raise an exception that will let me see what went wrong, or at least make it clear to me something went wrong, and then I can try to make sense of that message. Though typically when I'm running this way, I end up having to go look at the notebook run to see what happened. The error I get back is usually not as helpful, but you could put in more effort than I have on that status that you send back, and try to get all the appropriate information back in the status instead of the way I will show you right now. So when we want to run concurrently, we have threading and queue that we're going to use. Check the description if you want to understand more about this. I've talked through it before. If you want to know more about the exception handling, that's new. I'm going to talk about that in a future video. So for now, the key is that each time we try and run something, it's going to get a value off the queue, which is all of the args, and it's going to call the load table function with those arguments. So here's the notebook we're actually calling as we set up 4 different workers, right? 4 different threads, call each one for a different table. This is the notebook that's getting called, and just these values in the widgets get changed depending on what args we pass along. So looking at this, I'm going to mount storage again and make sure I authenticate one way or another. You could either call the mounts or the authentication depending on what you're doing here. Similar types of setup to what I showed you earlier on the other notebook. I'm also enabling change data feed here, which means I could go and get rid of it in that other notebook we walked through. Now is where we start to get into a little more specific processing. So let's see here. So my arguments are kind of handled pretty typically. I set table to whatever the table value was, ID column to whatever ID to whatever ID column was. And then with columns, I do something a little bit different. If you had multiple fields that represent the join that you need to use. So in this case, I just had area code, but let's say it was area code and I don't know, region or subcode. I could pass in a comma delimited string and then split that out into a list here. That's what columns is all about, which adds a little bit of complexity in the following steps. What we're going to do is basically read in a raw data frame. So this is a pretty basic Spark read that uses the raw base path and then the table name. And I'm going to add a column for is deleted and set them all to false. So obviously if it still exists in the source, it has not been deleted and I can leave it set to false. If your source system has a deleted flag, I'm not sure you even need some of these steps for deleted. You definitely would not hard code them all to false. You would take whatever the source system says. Stepping into here, I have a try statement just so that we can handle if the table already exists. But inside the try, these 2 lines are saying if the table doesn't exist, then go ahead and, or if the table does exist, I'm sorry, the destination refine table does exist, use delta table, specify the path so that it can pull in the table that it needs to, and then go ahead and change that to a data frame right here and filter out to only those that are considered not deleted, only those that are still around, have not been deleted in the past. And what we're going to do with it is say, has anything come in as deleted that was not deleted before? The accept statement, I won't get too much into, just know that there's a couple of error messages I've seen across the different runtimes that indicate the Delta table doesn't exist. Perhaps there's more that I would need to add, but these are the only ones I've encountered. And so if it doesn't exist, I want to go ahead and just create the table by writing out whatever data I got in the source, I'm writing out to the destination, and I'm going to exit with success. That's what's happening there. And so once I exit, it's returned back to the calling notebook, and there's nothing else that happens. I don't do any of these other steps here if it's the first time I'm loading up the refined table. Now, assuming it's not, assuming this table already exists and I'm processing a new batch of data or a new day's worth of data, which is probably a full snapshot of it, this little piece is really just to deal with those compound keys where we have multiple fields make up the join key. So what we do is we say loop through the list of IDs and build up a string that is going to be target table column value equals source table column value. And so if it's area code and subcode, it would be area code, key area code equals S area code, and T subcode equals S subcode. That would be the join condition I pass in. If it's just a single field, then I'm using this. T.id equals S.id. Pretty straightforward. Now, to check what has been deleted from the source is a way to do that just by kind of narrowing down what we're looking at by taking that source data and selecting out only the ID fields. And then I can do a join. So I'm taking target, join to source, and I'm doing it based on the join condition I just talked about a moment ago. And I'm doing a left anti-join to get back only the ones that do not exist in the target. And then at this point, I want to go ahead and add a with column for deleted and say is deleted is true. These are only items that have been deleted. And pretty often nothing's been deleted for this data I'm working with. But potentially it could happen, and so I've got a test case I've run to prove out that this code works. Another step to this is to upsert if any columns have changed. Okay, so in this case, I've got a list of columns that I want to exist in the refined table, and so update dictionary is going to build out a list of basically column names and in the Delta table mapped to source column names. And so any column that's not part of the ID will end up showing up here in the update dictionary, and it's going to go ahead and update those fields if we find a match on the ID and we tell that something has changed. Now, in order to tell if something has changed, right, to tell if anything in that row has changed, we use this condition string, which is going to, in a similar way, loop through all of the target columns and their source column match and say if the target column value is not equal to the source value, then we have a condition where an update needs to happen. So we go through each of the columns we care about and say, does this equal the source value? Does the target value in refined table equal the source value in my new data set? And so if any of those are not a match, this condition string will identify that and tell us we need to do an update. Here is where we union together the full source data with whatever's been deleted. Remember, we added these deleted flags, so we want to make sure those deleted items are included the first time that this runs with those deleted. So here in the Delta merge, what we're looking at is that the Delta target table, which will alias as T to make this all simpler to work with, will merge with Delta source or the DF source, which will alias as S. And then that ID string we built up earlier, a lot of times it's just going to be source.id equals target.id. That ID string is going to be used for the join. So the first two lines of it are doing the join conditioning. And then what we define next is what happens if there's a match. So when matched, update. And in simpler scenarios, you might do a when matched update all. If you only have changes coming in, you do a when matched update all and you're done. It's pretty simple. In this case, I want to actually check if there's changes. That way, when I'm building out my change data feed, I don't end up updating every single record every time just because it still exists in the source data. So really what we have here is a special check, which is going to take a little more processing time, of course, to say, have any of my columns besides the ID columns changed values since what's already exists in the refined table. So that's what this line of code around when matched update is doing. Finally, when not matched, so if this is a new field, go ahead and insert it. So when not matched, insert all. And then finally, we end that with an execute, which is going to kick off this merge statement. After all that processes, assuming it doesn't encounter an error, then we're going to exit with success, which returns back that success value to the calling notebook. And that's how we do our refined processing. And so just a quick recap is that what we've got is all of the data coming in the source file each time, though we're worried there might be deletes, and we know there's going to be updates from time to time. When refined, we've got all of the destination data with a deleted flag set to true or false. Most of them are going to be set to false because they still exist. This is going to say, look through each one, check if the field, if the deleted flag has changed from false to true, make that update. If the any of the values other than the IDs, any of the values have changed for a matching record, update that record with all the changes. Otherwise, if it's a brand new ID, insert. If it's the case of the IDs match but nothing has changed, don't do anything. So we're not touching the ones that have not changed other than to do the comparison and see if we need to update them. Okay, so there's quite a bit happening here. It's going to be tougher to do this with a full source data set every time if you have larger tables. But that's what's happening with refine. Next, what I want to show though, we've run that, it works successfully. How do we use the change data feed for curated to do its processing? Okay, now we're going to kick off curated, and you'll see a lot of similarities here, but let me still just kind of briefly talk about each one. So first in curated, we're going to build up our list of paths. We now are focused on refining curated. We don't really care about raw at this point. We're going to set the formats, of course, and we're going to set up our curated database if this is the first time running. All right, so we've made it that far. All of that's pretty familiar. We have a load table command. It's, I think, slightly different. Definitely the difference that is important is that I've hard-coded my notebook name and I'm using NB curated instead of NB refined. That's the big difference here. My arguments are being set up down below, and the rest of it really should be the same here. So here's the table list I'm going to use. I am not touching the current table yet. I've got a special step for that. But for area, series, and item, these are all dimension tables from my perspective as I'm going into curated. Curated is like your gold zone if you're thinking of the Databricks medallion architecture. So these are the tables that we're really expecting to build reports off of. Maybe even like public facing numbers are going to come out of these curated data sets. And so we typically model them more like a star schema, same type of similar data modeling, I should say, maybe not the exact same, but similar data modeling to what I've been, taught my whole career before the data lake concept was a thing, and the data lakehouse concept was, no one would have dreamt that up back then. So we're doing this star schema type design here for dim area for area dimension, dim series for series dimension, and dim item for item dimension. For each of these, we define an ID column, and that's pretty much what we need to send in there because we've already set up the fields we care about and the refine layer. Okay, my threading and queuing is going to look the same. I have some exceptional handling here, but nothing significantly different than the other notebook. So when it ran, we can see it ran each of these and had 3 successes. Let's go look at what's happening there and then come back to what we do for the special fact table. In curated, we have widgets again that look very similar. We mount our storage, we set that up, we set our paths again, and then we enable change data feed, which is still valuable. I think it's still valuable to have this on curated. You could probably get away without it, but when it comes to like data quality and auditing reports and things like that, you're probably going to want to have this on, is my expectation. Okay, so to prepare the tables, we're basically just grabbing grabbing the argument values and importing what we need. Then we're going to upsert any columns that have changed. And so the way we do this is we set up our Delta table for the curated database destination table. We're going to check our last modified date that we loaded to this curated table in the past. Get that last modified date, the max last modified date, right? We're going to go back 1 second basically, go forward 1 second, and then find anything that is in our change data feed that's changed since that time frame. So here's the big thing. The read format delta starts off the same, but then we have this option of read change feed. And that's going to add additional fields to what we read, and it's going to automatically filter down to things that have changed. And so we're not reading from our full data set. We're now filtering based on this read change feed and starting timestamp condition right here. After that, so we've set the change data feed, we reset the timestamp, we load up everything that's changed since, starting with that date. We are going to rename some of the columns that come with the change feed, or one column. We're going to rename commit timestamp and call this last modified. So all of my changes to refine happened on this commit timestamp. We'll name that last modified so we can keep track of that in the curated tables. And we're going to drop the commit version and the change type. I don't really, because I have a true false flag for deleted, because I'm going to set a last modified time, I don't really need to keep the commit the change type that tells me if it's update or insert, in my opinion. Okay, so we've got all that built up into a data frame. We still haven't saved it yet. We're going to set up another update dictionary, which is similar to what we did in the previous refined notebook, where we loop through all the columns and say, hey, here's the column name, and then here's the source column name. It's pretty straightforward. It's just a format that'll work well with the merge statement. Next, we take our target table and give it alias T for simplicity. We call our merge statement, and we do, that's the whole refined change feed for the filters we applied. And we're going to compare ID to ID here. Yeah, in this case, I'm assuming a single ID. I took out some of that logic that's more complex. And the reason is that I'd probably come through and work on some type of ID that's going to live with this long term rather than having 2 or 3 fields as the combined ID. So this may not work in every situation right now. If you have combined IDs, you'll need to still do something about that before you get to this step. And then finally, we have similar ideas to before. When matched, we want to update everything in the update dictionary. And in this case, though, we know that when it's matched, something's changed because we're reading our change feed. So I don't have all that extra conditional logic, and it should be much quicker. I've got a smaller data set coming in. Everything's either a change or an insert. And so I can just assume that, right? When matched, go ahead and update it. If it's an insert, go ahead and insert it. And I'm doing that for a much smaller set than I had to do between raw and refined when I didn't have change data feed in the middle. All right, then finally, I've got a table condition, much like before, to say if it failed because the table doesn't exist, do a whole different set of logic. And this should all still be working properly. I've done it and tested it before. So I'll pause for a second so you can take a look at that if you want, but it's a very similar type of code to earlier, but we don't have as much logic around. We don't need to do a delta merge. We need to do just a initial delta create statement here. And if it's if it's an error that's something different than that, then we would go ahead and print out what that means. Okay, and that's pretty much what that looks like, and that completes our curated steps for all of our dimensions. Now when we get to the fact table, here's where I think this is completely working, but it's not. Like I said, this is an example, and the curated piece is a little bit more fine-tuned, or it's making more assumptions about the target data and the input data than my refine. My refine is really meant to work with almost any data set I pass into it. But regardless of all that, what we have is we have a fact table that we want to call fact current, and we're going to pass in the source table name of current, or set the source table name to current. All right, we get a target table, much like before. We go ahead and do some logic to get the change feed like we did before. And then the big difference is once we get that change feed on the refine level, we want to actually do some joins to dimension tables and use the ID, just keep the correct ID rather than using the business key basically. And so here when I get to the Spark SQL for my fact table, I'm only dealing with changed records now, but I'd be pulling together all of the records that have changed or need inserted, and I'd be getting the correct dimension key for them instead of using whatever IDs and things came with it from the start. Okay, so as we get to there, I define the columns I actually want to keep. I do my delta merge right down here. It's a very similar concept as what we've been doing all along. And I know that everything's an insert and update at this point, so I don't have to do those extra conditions like we did in refined again. And of course, some type of error handling to try and catch if my tables doesn't exist. I need to do special logic the first time. I think here I would need to go build that table logic still for the fact. I believe I kind of had an expectation I would bootstrap the fact. So you either take the same type of logic from before and apply it in the except case, or you handle that initial fact creation outside of this as a special scenario, which I often find is the case. But in this demo, you could probably get away with just having that same type of logic to build the table the first time put right here. So that's the end of our demo. We looked at the refined notebook. We took a look at using Delta Lake and Delta Merge along with the change data feed, which I think is a really cool feature, especially if you can get more information about the data changes upstream and not do so much of it in the notebook. I think you'll be better off. If I can, I'll follow up with some information about that type of scenario and some performance tuning and things in the future. So thanks for joining. Hope to see you next time.